Welcome back. So, video 3, one population mean hypothesis test. Okay, so here with hypothesis testing, you got to remember that we have some type of guess on that population parameter. We have some type of idea. We have some type of intuition that we're trying to test if it's plausible based on the data. So, some assumptions for the one population mean hypothesis test is that the data is random and the observations are all independent. So, make sure you remember that random, random, random statistics. Everything has to be random, and then independent. All the observations have to be independent. To draw valid conclusions from a hypothesis test, both conditions must be met. Okay, so when it comes to hypothesis testing, we have to state our hypotheses. Okay, so depending on the situation at hand, you may have a right tail test, a left tail test, or a two tail test. Okay, so right tail test, we're looking at the distribution to the right. A left tail test, we're looking at the distribution to the left. And a two tail test, we're looking at both sides of the distribution at the same time. Okay. And so what's important here is that you are able to, one of the key elements here is that you're able to find out based on the statistical question whether you're looking at a right tail test, a left tail test, or a two tail test. That's key. That is key. Another big component to look into is, with regards to hypothesis test, is the test statistic. And knowing what the test statistic means for each and every test that we go after. So in this particular test, this tells us how many standard errors X bar is from mu. Okay, X bar, remember, is our sample statistic, mu is our population parameter, and S over square root of n is the standard error of the sample mean, which is X bar. So make sure that you're aware of that. Okay, good. Okay, so here, which is important, but sometimes you may have the population parameter for the variability, which is sigma. So if sigma is known, you use sigma. If S is known, if S is only known, you're going to use S rather than, because you don't have sigma. Okay, and so here, this could have been an easy, nice little review, right, in terms of symbols, but went ahead and just gave you the answer. X bar, sample mean. Mu, population mean. S is the sample standard deviation. N is the sample mean, a sample size. Ooh, sample size. Sigma is the population. What? That is not correct. Population. When I make a mistake, it's good for me to do that so that you all can see and then make that change on your notes as well. Standard deviation. Standard deviation. Oh, Google, thank you. Oh, my hands are typing pretty good. Okay, so in order for us to know what distribution we're actually going to determine whether we're going to reject or fail to reject our null hypothesis, right, is going to be based off of these conditions. So if n is less than 30, S is given to you, right, or nothing stated about the distribution, we're going to use a T. So all these conditions have to be met, and so therefore I should say and. All these conditions have to be met in order for us to use a T distribution. Otherwise, we use a Z. So we have a large sample size, Z. Sigma is given to you, Z. We know that the distribution of the data is normal, Z. Okay? So rewind that 3 or 4 times because that is a stumbling block every quarter that I've taught this class. Okay? So when it comes to hypothesis testing, here's the statistical process. Here are the questions that you must go over in order for us to thoroughly understand the context of the problem. So you know what I did again, just like I did in video 2, I provided us with an example. Okay, an example. So let's go ahead and read it together, and then I'm gonna have you all press pause and answer these questions. So let's say we're interested in the average height of current Cal Poly students. Your friend claims that Cal Poly students are short, with with their average height being less than less than. All right, I'm giving you a key right there. Less than the United States average of 67 inches. Okay, a random sample of 52 students were surveyed, and their average height was 65 inches, and the standard deviation was 8.23 inches. Do not. Do not include alpha or significance level. So you should. We're not talking about that here. Okay, we're not going to be talking about that here. Okay, is your friend correct? So go ahead and pause the video and go ahead and go through the statistical process, steps 1 through 11. Okay, you unpaused it. Good job. So let's go through this. I guess the first 5 steps we can go together. All right, the first one, the statistical question, is the mean height. I should I'm gonna say the population mean. Be a little bit more specific. Is the mean height is the population mean height of all CP students less than 67 inches? Our population of interest is going to be CP student. A observation unit is going to be a CP student. State how the data was collected randomly. State the variable of interest. Height as a quantitative variable, right? Oh, I'm getting ahead of myself. Height of a CP student. Okay, it's a quantitative variable. The summary statistic is going to be what? The sample mean. Good job, 65 inches. Best way of looking at it, I love a histogram. I love a histogram or box plot. Okay. Let me just put this in red, and then I'm gonna go ahead and go back to make that change. And please make sure you when I'm writing this, you make come on, stop embarrassing yourself, Dr. Williams. Okay. That's why I'm messing up because that's in my way. Okay. Boop. Bam. Okay. So I'll just highlight this, make this red. Okay. Okay. So then from there, and I want to say population mean. I want to say the population mean. I can't see. Okay. Population mean. All right. So then from there, state the inferential technique to answer the statistical question and view assumptions, right? Talk about the assumptions. Ideally, since we're in hypothesis testing, you should have said hypothesis testing. The students are independent and are random. So those are the assumptions being met. State the non-alternative hypotheses, right? So the null is going to, I'm going to hit myself. I might as well just show everything. All right. So here, state the non-alternative hypotheses. Wow. Right. The null H naught, some of your teacher could have used the null. They probably maybe used n, I guess. I use 0. Mu is equal to 67, and then the alternative is that mu is greater than 67. Stated in words. So when you see this on an assessment, you have to state not only just the symbols but also the words. That indicates to me that you understand the actual symbolization. So you need to be able to explain it in words. And look, I made a mistake. It should say the population mean height of all Cal Poly students. Okay, the population mean population mean. Okay, make sure. Okay, and so make sure you're able to articulate that in words. The next big thing is this test statistic, right? The test statistic. The test statistic here tells us how many standard errors X bar is from you. Okay, how far is 65 from 67 in terms of standard errors? Here we get a standard error of negative 1.75. That tells me how far again the sample mean is from the population mean. Okay, and so here that tells me that it's not that far. It's not that negative 1.75. It's not that far. Okay. Our degrees of freedom is 51, I believe, yes. And our p-value, as we mentioned in class, the p-value tells you the likelihood of you observing this sample given the null hypothesis is true. The likelihood of us actually seeing 65 as a sample mean given that our population mean of those actually left Cal, no, not left, the height, the height of Cal Poly students is 67. Okay, and so with that being said, that's not that much evidence to reject the null hypothesis. It's not that much evidence. I'm not convinced. I'm not convinced. So with a sample size of 52 Cal Poly students, we would reject it, but it's not a strong rejection. It's not like we have strong evidence. We have a little bit of evidence, but we have a little bit of evidence to reject it, but not a lot. Not a lot. Okay. So keep that in mind, and then you can write out the instructions. The key would be posted, so don't fret. Um, and yeah, that's all, folks. I'm trying to find out a final line. That should be a question. Like, what should I end the videos on? That's all, folks. That's not my line. All right. Have a good day. Thank you.